We pick our ball pen once again and then we start section A. All right. In this network of resistors connected in both parallel and series arrangements, we are expected to calculate the total resistance in the entire circuit. Before we continue, or before we delve into detail of all this, I want to use this opportunity to welcome you, ask you to drop your topic in the comment section, right? I will solve it for you. I will teach you. I will make you understand it. In so doing, I want you to also support me by promoting this channel. All right? Give me some thumbs up. Come on. Share with your friends, with your networks, with your colleagues, with your students, with any family that you know that wants this for their children to learn. All right? Give me some thumbs up. Come on. Put on the bell button for constant notification each time something like this is uploaded. All right, thank you so much, my returning subscribers and also my new subscribers. I am so proud of you people. Now let's delve into it. Section A is very important here. We simply have section A and we're going to state the formula 1 all over RT. I'm going to be fast a bit here. Since we have done the first one, RT, we already know that the total resistance offered in a circuit, especially when such resistors are connected in parallel, can be calculated using the formula I am stating now. All right, so we have a section A, we have 2 resistors. That means R1 plus, all right, 1 all over R2. Okay, very good. All over R2. Good. So if we quickly substitute for this, we will have 1, okay, for 1 all over R2 for the first resistance, and then we have plus, all right, 1 all over 1 for the second resistor, or offering resistance 1 ohm. So if we calculate this, this is very simple. It's going to give us a total of is equal to, we're going to have total of 2, all right, all over 3, all right, 2 all over 3. That is the total resistance here, and it is measured in ohms. So let's take notes without wasting time. This is very simple, right? So our RT here is 2 over 3 ohms. Okay? Yes. I want you to understand what I did to get this. I just did 2 times 1 all over 2 plus 1. That's what I did, okay? All right. Then let's look at the second section. That is section B. We are going to look for the total resistance for 3 resistors connected in parallel, offering different resistances such as 2 ohms, 3 ohms, and 1 ohm respectively. So 1 all over RT, that's the total resistance we are asking for or looking for, right? It's going to be 1 all over R1, right? Let's take notes. All over R1, okay? And then the next one is going to plus 1, right? All over R2 for second resistor in that arrangement, okay? I'm just trying to manage the space and make things as clear as possible. That's going to be plus, once again, 1 all over R3, okay, for the third resistor offered in that circuit or in that section. So we have that. We have stated the formula. What do? We quickly substitute 1 all over 2 for first resistor, offering resistance 2 ohms, then plus, all right, 1 again, all over 3 for second resistor, offering resistance 3 ohms, and then we all go again plus 1 all over R3 for third resistor offering resistance 1 ohm, right? Very simple. So the next thing we need to do is to quickly find the LCM. I have taken time to explain what LCM is all about. LCM simply means that number that 2, 3, and 1 can divide without a remainder. That's what it means. So what is that number that 2 can divide, 3 can divide, and 1 can divide it without any remainder? At least we can see that here 2 and 3 can divide 6. Also 1 can simply take the whole 6, right? Very simple. So the LCM here is going to be 6. All right, let's quickly move on. 2 divide 6 is going to get 3 each. Then that 3 each multiplied by this one remains 3. So we have not changed anything. Then another thing we need to do here is 3 divided by 6. Okay, if we use 3 and divide 6, each will get 2 all through, right? Each of them we get 2. So 2 times 1 is going to be 2. We have not changed anything. So what happens next? Now is only 1 remaining, right? We need to know what happens here. 1 divided 6 is going to be 6, completely 6. Taking that alone times by 1, so 6 times by 1, or 1 times 6 remains 6. We have not changed anything. Okay, we have not changed anything. Let's correct our 6. It looks a bit encroaching. Okay, it's encroaching into the division line, so we need to correct that quickly. So we have our 6, all right, unchanged. Good. So the next thing is adding them together. By the time we add 3 plus 2 is 5, 5 plus 6 is 11. So we have 11 all over 6. All over 6. Good. So remember we have 1 all over RT. Okay? We have 1 all over RT. That is it. Good. So now what do we do? What we are going to do is to multiply both sides. Okay? Both sides using inverse. This is inverse at this side, and then we go this side again, multiply using inverse for us to be able to quickly make R subscript T the subject. Okay, so we take it up from here. Look at, we are going to take it up to this point. We are taking it up above to finish everything here. All right, so that is what it means. What it means at the end, we are going to have for the second section B, RT is going to be now 6 will come up, becomes 6 all over 11. All right, all of 11, and that is our answer, 6 over 11 ohms for this section B. The total resistance offered in this section B, okay, is 6 all of 11 ohms. The total resistance offered in this section A is 2 over 3 ohms. 2 over 3 ohms. Look at it here. So the total resistance for this side is this. Found. Very simple. Now it is time for us to go on and then add. We have 2 over 3 ohms. We now have 6 over 11 ohms for the respective parallel connected resistors offering different resistances. Now it is time for us to connect all in series and see what we have. All right. By the time we connect all in series, you can see we have a beautiful arrangement, and that will give us this quickly. We have this. All right, and then the second one is the total resistance we have in section is in series. Okay, that is 5. Then the third section is going to be section B, where we have another parallel connected resistors. All right, please don't mind my diagram. I'm just trying to illustrate something for our learning pleasure, right? Good. So with this, we can illustrate that for this point, we have 2 over 3 ohms. 2, okay, all over 3 ohms. Good. For this point is already given as 5. All right. So this is given as 5. Then for this side, we have 6 over 11 ohms, right? Good. So that's what it means. Our unit remains ohms altogether, right? For each and every one of them. The unit is 5 ohms here, and the unit is 2 over 3 ohms here. All right, so what do? We add. Very simple, we add. And the formula for that is RT, okay? RT is equal to R1, okay? R1, good, plus R2, which happens to be the resistor with 5 ohms, and then the other one is going to be R3. That's what it means, right? R3. Good. So the next thing is to substitute accordingly. The next thing is to substitute accordingly. The next thing is to substitute accordingly. All right. Once again, let me remind you, if you have watched up to this moment, why don't you consider subscribing to this channel? Because you know what? I am going to upload numerous assorted topics in physics, topics in chemistry, topics in mathematics, just name it. Above all, I want you to drop the topic you want me to teach for your learning pleasure, for your learning gain, right? But don't forget to give me some thumbs up, share with your friends, with your students, with your family members, with your colleagues, with your networks, right? Don't forget, in so doing, we are promoting learning. In so doing, we are promoting learning, all right? All right, let's continue. So for R1, we have 2 over 3, okay? Good. So let's see what happens. I'm going to be fast a bit. Bear with me if the video is becoming longer than expected. Teaching has to be something that is procedural, right? You don't just hasten teaching. You don't just speed up teaching. No, one has to understand. And by the time you speed up teaching, you are denying the learner the space to learn, okay? You are denying the learner the opportunity to grab the concepts, to grab the understanding, right? Thank you for your understanding and for your cooperation. So for R2, we have 5. We are going to use all over 1 to make it fractionally uniform, okay? Then for R3, we have 6 over 11. Very simple. I'm not going to waste time again. I'm going to go straight and then conclude. Here we have what? What do we have here? Quickly, of course, the LCM once again here is what? 33, because 11 and the 3 can divide 33. Yes. Yes. Is there another thing? 11 and 3 cannot divide 22. No. Okay. 11 can divide 22, but 3 cannot. Are you with me? Good. So I think the LCM here is going to be 33, and we'll move on with that because I don't want us to move beyond this level. Okay. Okay. Now 3 divided 33 is 11. 11 times 2 is 22. See how it goes. Quickly, 22. All right. Good. We put our plus sign. What do we do again? Let's extend this line to accommodate all of them. 1 divided 3 is 33. 33 times 5. 30 times 5 is 150. 3 times 5 is going to be what? 15. So 150 plus 15 is going to be what? 150 plus 15 is going to be 165. 165 for the second one. Okay, learning continues. The last one is very simple. 11 divided 33 is going to get 3 each. So what do? That 3 multiplied 6 is going to give us 18. 18, right? Good. So at the end, our answer is going to be 22 plus 165 is going to give us 185. 185 plus 18. Okay, 185 plus this 18. What are we going to get? So 185, let's just do small calculation here. 185, all right? 185 plus 18 is going to give us 1 something or 2 something. Let's see. Okay, very simple. 5 plus 3 plus 8 is going to be 13. You write 3, right? Carry 1. Put here 9 plus 1, 10. Write 0. Carry 1. Put here becomes 2. So we are going to have 203, right? By the time we sum this, we have 203. But because of time, 203 over 33, the inverse is going to be 33, right? 33 all over 60. Sorry, all over 203. My mind went to 60 once again because I once calculated 60. All right? Okay, it's going to be that. Very simple. So this becomes our final answer. Cross check. Yes, I want you to cross check. Remember, it's measured in ohms. All right? Yes, our answer is measured in ohms. So take notes. Okay, this is our answer now. Very, very important. Very, very important. This is our answer. 33 over 203 ohms. By the time we divide 33 over 203 ohms, we're going to get small amounts of resistance. 0 point something, 0 point something something, right? Good. So the total resistance in this network of resistors connected in both parallel and series is 33 over 203 ohms. If we find the equivalence in decimal points or decimal numbers, we are going to have 0 point something, okay? And that is what we expect to have. Thank you so much for watching. Thank you for bearing with me. Thank you for cooperating with me. And then thank you for taking the time, all right, to watch up to this moment. Once again, if you have found value in this, consider subscribing. Consider sharing with your networks, with your friends, with your students, with your family members, with everyone, with any family that likes something like this. Who knows, you might be helping out somebody somewhere. All right, drop the topic you want me to teach. I will do exactly what you want from me. Thank you so much. Watch my next video here or watch it somewhere there. It will be linked. Thank you. See you in my